Hello everyone. In this recording, let's go through the solutions of question number 7 in Project 2, which is meant to be a preparation for test 2. I'm going to first read through the question. It says here, a researcher wants to investigate the causal effect of two factors on human performance. Sleep deprivation is the first factor and caffeine dosage is the second factor. This is an experimental design because participants were randomly assigned to different treatment combinations. The goal is to see if these factors individually and in combination affect the reaction time measured in milliseconds or ms, and below is a table which gives us the means of the reaction time with the combination of different levels within each factor, or within the two factors really. So let's go through the question here. The first question says, describe the type of factorial design of this experiment. Now, in order to describe the factorial design, we have to consider the levels within each factor. So the first factor is sleep deprivation. Let's see how many levels we have within that. 2. One is the standard sleep of 8 hours and the other one is the sleep deprived condition, which is 4 hours of sleep. So there are 2 levels within factor A, and then we put the multiplication symbol, and now let's look at the levels within the second factor, which is caffeine consumption. There are 3 levels within caffeine consumption, so that's placebo, low dose and high dose, correct? So it's 2 times 3, that's the factorial design. So if someone asks you to describe the factorial design, just look at the number of levels within each factor and write it in A times B form, right? A being the levels within factor A and B being the levels within factor B, right? And 2 times 3 also will tell us how many cells there will be in this table structure. We see 2 times 3 is 6, correct? And we have here 6 cells: standard sleep, placebo, standard sleep, low dose, standard sleep, high dose, and same for sleep deprived, and each of these categories or levels within caffeine consumption. Right? So that answers the first question. The second question says, identify factor A, factor B, and the levels within each. I think we already talked about that, but here we just need to write it down. So I'm going to go ahead and write down what factor A is. Factor A is sleep deprivation, and within factor A, the levels are standard sleep and sleep deprived, and factor B is caffeine consumption, and then just write out the levels within that factor. So I'm going to pause and first write down the answer for this and then come back. So let's go through how I've written out the answer for B. I have factor A, which is sleep deprivation, and then the levels within factor A are standard sleep for 8 hours and then sleep deprived state of 4 hours. And then for factor B, it was caffeine consumption, and there were 3 levels of it. The first was the placebo of 0 milligrams, then there was low dose 100 milligrams, and high dose was 200 milligrams. So that's all that it is. All right, you just have to identify the factors, the levels within each factors, and write them out. All right. Now question C is asking, identify the response variable. Now, response variable is the variable that is being measured, right? It's not standard sleep or sleep deprived or placebo, low dose and high dose. It's what is being measured. So I'm going to go up to the question above, and over here it says they are trying to determine if the factors individually and in combination affect the reaction time measured in milliseconds. So the response variable, what is being measured is the reaction time in milliseconds, and that is the answer for part C, right? So the response variable is going to be the reaction time in milliseconds. Now the final question, part D, says state the hypothesis for this test. Now for this test there's going to be 3 sets of hypothesis statements. The first one is for factor A. For factor A there's going to be a null and alternative hypothesis. Then for factor B there's going to be a null and alternative hypothesis, and then for the interaction between or the interaction of the 2 variables on the reaction time, that's going to be the third set of hypothesis statement. All right, now again, null hypothesis will always say for both the factors as well as for the interaction effect, it's going to say there's no effect. None of these factors, whether separately or whether jointly, have any effect on the reaction time. Whereas alternate hypothesis is going to say yes, it has an effect. So there are going to be 3 sets of hypothesis statement. Again, I'm going to first write out the statements and then I'll come back and go over it. All right. So now let's look at the hypothesis statements that I put together. The first one is the main effect for factor A, the main effect hypothesis statement for factor A. The null hypothesis states sleep deprivation has no effect on reaction time. Alternate hypothesis states sleep deprivation has an effect on reaction time. The main effect of factor B, which is caffeine consumption, states for the null hypothesis, caffeine consumption has no effect on reaction time, whereas alternate hypothesis will state yes, it has an effect on reaction time. For the interaction effect, the null hypothesis stating sleep deprivation and caffeine consumption together have no effect on reaction time, whereas alternate hypothesis will state sleep deprivation and caffeine consumption together have an effect on reaction time. Okay, so this is the solution for all the questions under the question 7 on two-way ANOVA design.